Good morning, Blue Cultural Group. This is an astronomy lesson. And following up on yesterday's lesson where we talked about the origin of our solar system, today we're going to talk about the planets. But before I do that, I want to review with you how our solar system came to be. It's a fascinating story. Remember, gravity pulled together the gas and the dust from the center of the nebula cloud. And then the cloud began to flatten out and began to rotate, because that was the motion from the Big Bang, around its center. And the currents and the eddies in the cloud swirled around, and it caused smaller amounts of the matter to collect at various distances from the center. The heavier elements were pulled because they had more mass. They were pulled in towards the center to become the four inner planets. And the lighter elements stayed farther out as the five outer planets, the gaseous giants. For millions of years after the planets condensed, they were bombarded by meteorites. So the solar system no longer has the appearance of a cloud nebula. Now most of the gas and dust that's left between the planets has been swept away by the solar wind. You can see the scarring that the meteor craters have left on many of the objects in the solar system by looking at photographs of our moon, which we'll show later when we deal with the moon carefully. So what I want to do today is I want to take you on a tour of our solar system, planet by planet, object by object. So here we go. Oh, and I want you to, I'm going to be talking about the relative size of the planets. So it's really useful, I think, if you guys get yourself a ruler or a meter stick, yardstick to have in front of you so you can compare the relative size of the planets when I give you some of these numbers for the comparison. So where do we start? Well, we start with the innermost object in our solar system. It's our sun. And this is my model of the sun. If I was to put this sun, if I had this sun compared to the relative size of the other planets, the diameter of the sun would be 12 feet. So if you got your ruler, 12 of those rulers, that would be the diameter of our sun. Well, let me just give you a few facts about our sun. Its diameter is 865,000 miles. It's made up of hydrogen and helium. Its surface temperature is from 4,500 degrees to 15 million degrees centigrade out in the solar wind. It's a medium star. It's yellow-white. It's 110 times the diameter of the Earth. And its power comes from a nuclear fusion generator in its core. And the black spots that you can see on the sun are sunspots caused by differences in the magnetic force field that surrounds the sun. When you're listening to Mr. T's lecture, I'm going to ask you to look at the photos that I've also posted on our Facebook page, because we're going to go through them one at a time. And these are actual photographs taken by telescopes from either the best of the earthbound observatories or from the Hubble Space Telescope. And these are real pictures of what the surface of these of our neighbors in the planetary solar system look like. So have a look at those pictures as I'm talking to you and giving you some information in addition to the model that I'm showing you. So the closest planet to our sun is Mercury. If the sun is 12 feet in diameter, Mercury's a 1/2 inch. So look at that on your ruler. Its diameter is only 3,032 miles. Its distance from the sun is 36 million miles, which is really close. And because of that, the surface of Mercury is extremely hot. Its temperature is 425 degrees Fahrenheit. And so it's basically a burned up crust of a planet because of its nearness to the sun. It has no atmosphere. The atmosphere has been entirely burned away. And because it's so close to the sun, it orbits around the sun in just 88 days. It's the closest planet to the sun, Mercury. Excuse me, as you know, Mr. T, the pollen count is incredible. When we walk around our neighborhood, we see all these beautiful flower trees, and that's the good news. The bad news is they're pumping out so much pollen right now that guys like me who suffer from hay fever have it bad at this time of the year in Virginia. Excuse me. The second planet out from the sun in our solar system is Venus. And this model, if the sun is 12 feet in diameter, this model would be 1 1/4 inches. Its distance from the sun is 67 million miles, almost twice as far out from Mercury, but it still has a very, very hot atmosphere and surface. Its radius, its revolution around the sun takes 225 days, 225 days, and except for the sun and our moon, it's the brightest object in the night sky. You can see it every night out there. Go out and look for it. Venus is a beautiful planet out there shining. Venus' atmosphere is made up of poisonous gases, sulfuric acid, ammonia, and its atmosphere is so thick that we hardly ever have been able to get a picture of its surface. A Russian spacecraft actually landed on it, and before it burned up because of the heat, it took some pictures that showed you that it's a very hot and very hostile atmosphere under this cloud of poisonous gas. So this is our second planet from the sun, Venus. Our third planet from the sun, our third planet from the sun is our Earth. And I put its moon next to it. The planet Earth, our home planet. If the sun is 12 feet in diameter, the Earth would be 1 5/16 of an inch. Not quite 1.5 inches. And we'll study more about Earth, and of course we do that in our geography studies and our geology studies with Mr. Smith. But the Earth's diameter is 7,927 miles. Its distance from the sun is 92 million miles, almost 93 million miles. And you recall that at the speed of light, it takes solar energy rays, photons of solar energy, it takes them 8 minutes to get to the surface of the Earth from the sun. The temperature on Earth is between 135 degrees Fahrenheit in the Sahara Desert to minus 130 degrees Fahrenheit down in Antarctica. It's the living planet in our solar system. It's the only one so far that we know of that has life on it. And partly that's because, or substantially that's because, it has liquid water. Without liquid water, life couldn't exist, and you see why we call it the blue planet. And when you look at the photos that I've attached to this lesson, you'll see our beautiful blue planet with its surface of blue water and white, wonderful clouds. fourth planet from our solar system, from our sun, is our neighbor Mars. Once again, relative size, if the sun was 12 feet in diameter, Mars would be 11/16 of an inch. So it's substantially smaller than the Earth. Its diameter, that's the line drawn through the center of the sphere, is 4,212 miles. Its distance from the sun is 141 million miles. And that means that its surface temperature is only at its highest when it's closest to the sun, 65 degrees Fahrenheit. But then when it's far away from the sun or on the dark side as it's rotating, would be 190 degrees, minus 190 degrees Fahrenheit. It's a windswept desert planet. It has an atmosphere of carbon dioxide, nitrogen, and oxygen. And we've explored it with great detail because we've been able to send Mars rover robots to the surface of the planet to study it with great detail. Now. So those are the inner or rocky planets. And again, please look at the photographs that I've provided for you that you can see on the Facebook page as I'm discussing the various planets in the solar system. As I told you in the origin of the solar system, between the rocky planets and the gaseous giants, when the sun ignited as a nuclear furnace, it blew away the gaseous elements that were in the nebula, and those formed the outer planets as they spun around and the gaseous molecules accreted together, and it left the rocky planets. But there was a lot of junk, a lot of stuff, a lot of pieces left together that didn't accrete and form parts of the planets, either the gaseous giants or the rocky planets. And that junk is the asteroid belt, which is, there's about 100 million miles of width of the asteroid belt with tens of thousands of irregularly shaped objects in it. Rocky asteroid objects made of rock and sometimes ice. And you can see some pictures of them in the pictures that I posted for you. If we added up all the mass that's in all of those asteroids, it would only equal 1/30th of the mass of our moon. So even though there's thousands of these asteroids, they're relatively small compared to the other objects in our solar system. So moving out beyond the asteroid belt, we come to the first of the gaseous giants. This is my model of Jupiter. It's the largest planet. It's a fascinating one. It's a gaseous giant. It has a core that's rocky and made of frozen gas. So it has a small solid core, and inside inside the surface of Jupiter, the gas, because it's cold, it becomes viscous like peanut butter. So it's a gaseous giant, but the closer you get to the core, the more dense the gas gets. It's 88,000 miles in diameter. So if the sun is 12 feet in diameter, Jupiter is 14 7/8 inches. So it's bigger than a foot. So Jupiter's relatively big, but it's still really small if you compare it to our giant star, the sun. The diameter, as I said, is 88,000 miles. Its distance from the sun, golly, it's way out there, 483 million miles. Remember, we on our Earth are 93 million miles, so Jupiter is almost 5 times further from the sun than the Earth is. Its temperature on the surface is minus 150 degrees Celsius. Far away, the solar energy that hits it is not very warm like it is here on Earth. Its atmosphere is composed of the gases hydrogen, helium, methane, and ammonia. It's 11 times the diameter of Earth. It has the great red spot on it, and you'll see a picture of that in the photograph that I've put on the Facebook page for you. The great red spot is a cyclone. It's like a hurricane of gas that's been swirling about for thousands of years, and it's 20,000 miles long. Have a look at it. Jupiter has many, many moons. We can study them later. The biggest of them is Ganymede, and it's larger in size than Mercury. So this is our largest gaseous giant. And we've been able to send some of our satellites, our space probes, very close to Jupiter and to look closely at its moons. And some of these moons are fascinating in terms of their potential for life, whether they have liquid water, liquid methane on them. Really fascinating things that scientists have been able to learn as they continue to study the large moons around our biggest planet, Jupiter. Next, and please look at the picture that I've published because it's from a European space probe, and it shows our beautiful planet of Saturn, which has highly visible rings around it. Jupiter has rings, but they're barely visible to the naked eye and even to most telescopes. But Saturn's rings are very, very distinctive. The rings are composed of rock and ice boulders, and we've got some beautiful detail because satellites have been able, our space probes have been able to fly right through very close to Saturn and get close-up pictures of what it looks like. It's 74,000 miles in diameter. Some are smaller than Jupiter, which was 88,000. Its distance from the sun, again, is huge. It's 886 million miles. Remember, Jupiter was about 400, almost 500 million miles from the sun. Saturn is, again, another 400 million miles about further out from the sun than Jupiter. Its temperature, you expect it to be that far out, minus 180 degrees Celsius. The colorful rings around Saturn, ice, rocks, and dust, as I said. Some scientists believe that the rings are the remnants of moons that have collided into each other and shattered, and gravity, the pull of gravity from Saturn has kept that debris from those shattered moons in these distinct rings that circulate around, that circle the planet. Saturn has some large moons of its own. Some of them are stuck in the circle, inside some of the circles. And again, you see the picture of Saturn with its gorgeous rings on the Facebook page. We're going way, 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 way far out from our sun into the solar system. And we come to the 7th planet in our solar system. It's the planet of Uranus, or Uranus, depending upon how you pronounce it. I think both pronunciations are okay. So Uranus is, if the sun was 12 feet in diameter, Uranus's diameter would be 4 feet and 7/8 inches. So it's a large planet. Compared to the sun, it's small. Compared to our Earth, it's 4 times the diameter of our Earth. So it's a huge gaseous giant. Let me tell you, it's not been well studied. We've sent space probes that have passed near it. We have some great photos of it. It has a great spot storm on it, kind of like the red spot on Jupiter. And you'll see those pictures in the Facebook page where I posted them. Its diameter is 32,000 miles, 4 times the Earth. Its distance from the sun, listen, its distance from the sun is 1,783,000,000 miles. So it's way, way out there, much further out than Saturn and Jupiter. Okay? Its atmosphere is composed of hydrogen, helium, methane, and ammonia. It has at least 5 large moons. It was photographed by Voyager 2, the deep space probe that continues into interstellar space, even to this day. That was launched in 1986. And the ring system is vertical. Saturn's ring system is elliptical. The ring system on Uranus is vertical. And the last planet that we include in our solar system currently is the planet of Neptune. Another ringed gaseous giant. If the sun is 12 feet in diameter, Neptune is 4 and 5/8 inches. So it's a gaseous giant. Its diameter is 30,000 miles. Its distance from the sun, wow, is 2,794,000,000 miles. So the distances just keep getting greater and greater as these planets orbit around their home star, our sun. Again, the atmosphere of this gaseous giant is hydrogen, helium, methane, and ammonia. The surface temperature, that far away from the solar rays and the solar wind, is minus 200 degrees Celsius. We know it has moons. 2 of them have been named, Nereid and Triton. And future space probes will be studying more about this gaseous giant, the farthest planet out in our solar system. One of the pictures that I posted for you guys is a drawing of the solar system and the planets as they orbit around the sun. And I commend that to you to get an artist's conception of what the solar system looks like. And you'll see the orbits and the distances, the relative distances that the planets are orbiting from the sun. And I'll talk more about these in a future lesson. I haven't mentioned, when I was growing up, we understood that there were 9 planets in our solar system. And that was the exoplanet was Pluto. And Pluto was actually in the 8th position. Neptune was outside of it in the 9th position. But some years ago, the International Association of Astronomers and Cosmologists it took a vote. And they studied the planet, what was then a planet, Pluto. And what happened was that our more sophisticated telescopes began to discover out in the Kuiper Belt. The Kuiper Belt is like the asteroid belt, but it's further out past Neptune. And in the Kuiper Belt, astronomers discovered many, many objects that were the same size as Pluto. And so they had a problem of whether to add a 10th, 11th, and 12th, many more planets to our solar system, or demote Pluto from being an actual planet. And so they voted, and the scientific wisdom, the majority of the scientists said, no, Pluto will no longer be considered a planet. We'll call it a dwarf planet or a minor planet, but it won't be included in our study of the planets in our solar system. So that's how Pluto was demoted from being a planet and a member of our solar system family. Last thing I want to mention to you is comets. This is a drawing of a comet, and comets are part of the debris that's left from the Big Bang and the formation of our solar system and our galaxy. And so they consist of a matter that's accreted together. It's dust, it's major, heavy elements, and ice, and those comets orbit around the sun with huge orbits. So they come into our solar system very, very rarely, hundreds of years between the times that they pass through the solar system. And what's happening is, the reason they have that tail is that the comets, when they get closer to the sun, the ice begins to melt, and the dust and materials that are in the comet leave a trail behind it, and that trail is blown away from the sun by the solar wind. So comets are occasional visitors into our planetary system, our solar system, that have been seen throughout time. And in ancient times, they upset the people greatly because they could be seen in the night sky, and they were mysterious, and people wondered what they were. So now scientists, of course, are able to define them very carefully. We've actually sent space probes out near them to collect dust from their tails of the comets, and scientists know a lot more about them. So this has been a study lesson on our planets in our solar system. I ask you to go again to the Facebook page, and you'll see photos of all the planets that I've mentioned. And there'll also be some worksheets for you guys to begin working on, because now it's up to you to do planet research. And you'll see I'll publish for you guys reports, formats for you guys to do your own study. Go to research materials you have available, encyclopedias if you have them. Your moms and dads can help you go online on the internet to find information, and compose your own booklet of Who Am I Planet Research Reports on all of the planets in our solar system. And that way, by research, you'll make your brains really strong, and you'll become expert astronomers on our solar system. This is Mr. T signing off. Hope you enjoyed our study of the planets.